Now this illustration deals with sizing the conductors. For this three-phase motor, step 6, table 430.250, reference from 430.6a to this table, the 50 horse is 65 amps. Step 7, we calculate the load in accordance with Table 220.3. Now I'd like to point out Table 220.3 will refer you to branch circuit requirements so that you can know just exactly what a branch circuit requirement is. Also look at your table, say 220.3, because it also will give you information along with your table 210.3. And actually, this table 220.3 would refer you to 430.28 through a part of Article 430 to size your conductors, which would be 430.22 would be your section reference. 65 amps times 125% equals 81.25 amp. Now step 8, we have to apply 310.14A3 informational note 2 as well as table 310.16. So 81.25 amp requires a number 4 conductor. Now you must realize that this is kind of running the conductors and the conduit, say, in a paradise type situation, because there's no D rating. We only have 3 current carrying conductors, and the ambient temperature does not exceed 86 degrees Fahrenheit. Now, many times people taking a test get confused. They don't know where this 86 degrees Fahrenheit comes from, and the 3 current carrying conductors or less requiring no D rate. We'll just go to table 310.16, and at the very top of the table, this information is given. But the golden rule now for sizing the ampacity of a conductor, we would review 310.14A3 informational notes 1 through 4, and then there's no mistake, because you'd have 1 through 4 that deals with the terminal ratings that you would select. In most all tests, there's 60 degrees C, without they tell you otherwise, 75 degrees C. But you only have 60 or 75 degrees C. Remember, in the selection of the table, you do not select the 90-degree column without you D-rate. Now, that's it. That is in accordance with 3 or less current carrying conductors. 4 more, you D-rate 80%. The ampacity of a conductor, 7 to 9 is 70%, and so forth. When we review the table that deals with that thing, which is table 310.15c. Table 310.15b deals with the ambient type temperatures that you route it through that are above 86 degrees Fahrenheit. But don't do any of that D-rating or ambient temperature correction factors without the test calls for it. Most of the time it will not, but just in case it does, know where to go for, say, 4 more current carrying conductors. Go to table 310.15c, as in car. For ambient temperatures, where you're routing basically more than 10% of the run, or 10 feet through a higher temperature than 86 degrees Fahrenheit, go to your table 310, say 15b. Now, Chapter 4 gets into these derating and ambient temperature problems in great detail. We'll be coming up on that later on in this presentation. But right now, we're just sizing the conductors, and so in the solution, from step 8, we would select a number 4 THWN copper conductor from the 75-degree column of our table 310.16 if they're 75-degree terminals. If they're 60 degrees C terminals, then of course you may need a number 3 conductor. So check it out and see what your terminal ratings would be. That's one of the test-taking questions that you ask the moderator. So our figure 1-17.3 is dealing with sizing the overcurrent protection device ahead of the conductors in accordance with NEC 430.52 C as in car 1, applying the exception 1 if you're sizing the overcurrent device. But if you're sizing the conductors, then we are looking at our table 310.16 based upon the 125% rule times the full load current rating in step 6 in accordance with 430.22. I would also recommend to the test taker, if you refer to the table of contents and look under Article 430, each one of these references for sizing conductors, overcurrent device, overloads, disconnecting means, and so forth is listed there. It's a fast reference. Now it'll refer you to the part that deals with that subject. And then you just scroll down until you pick up the section that deals with your subject matter. So in this case, it'd be 430.22 and table 310.16, as well as 310.14A3. So figure 1-17.3 is dealing with sizing your conductors to the motor. So this will conclude our figure 1-17.1.2 and .3.